Okay friends, let us see U2 manometer in detail. This is the figure of a U2 manometer. A U2 manometer is a simple manometer, and if you look carefully at the figure, you can understand that U2 manometer is nothing but a glass tube bent in U shape, English alphabet U shape, hence the name U2 manometer, and it is having two ends, end 1 and end 2. So one end will be connected to the point at which pressure is to be measured, and the other end remains open to the atmosphere. So we can say that this end will be connected to the point where pressure is to be measured, and this point will be, or this end, sorry, not point, this end will be open to atmosphere. Now U2 manometer generally contains a fluid which we call it as manometric fluid. Manometric fluid. The manometric fluid is not shown in the figure. I am going to draw the manometric fluid. So the manometric fluid can be any fluid. Usually we take mercury as a manometric fluid. Now the specific gravity of the manometric fluid should be greater than the specific gravity of liquid whose pressure is to be measured. So the so-called schematic of U2 manometer is very simple. A hollow glass tube bent in U shape and a manometric fluid. It is as simple as that. And how we are going to measure the pressure at the point using U2 manometer, let us see that now. Okay friends, now let us see how we are going to measure the pressure using U2 manometer. So here there is a pipe and a fluid is flowing through the pipe, and I am going to call that fluid as orange fluid. Orange fluid, because I have given orange color to it, that's why orange fluid. And we need to measure the pressure at point A. Okay, this is our case. So if we are using U2 manometer in order to find out the pressure, what we are going to do is that we are going to attach one end of the U2 manometer to the point, and the other end will obviously be open to the atmosphere, and this U2 manometer will be having our manometric fluid. It's in the violet color. And this part is open to atmosphere. So since we are attaching this end to the pipe, the orange fluid will flow to the U2. Let us draw a clear cut picture now. Okay friends, the same figure. Here we have our pipe, our manometer, manometric fluid which is in blue color. I am going to write it as MF. The open end, I am going to write it as OE, and the fluid, orange fluid. Now I need you to have a bit of imagination and intuition. atmospheric pressure is acting at the opponent. Okay, atmospheric pressure is acting at the opponent, and imagine that this atmospheric pressure is pushing the liquid downwards. I'm drawing that direction using a green color. The green arrows shows that. So imagine that the atmosphere or atmospheric pressure is pushing the liquids downward. Now the pressure inside the pipe or the fluid, on the other hand, is also pushing the fluid downwards. So I am drawing that direction also. If we imagine like this, that is, the atmospheric pressure is pushing fluid downwards, as well as the pressure at A is also pushing fluid downwards, we can draw a junction. Have drawn a junction such that the whole system, the pipe and the manometer, gets divided into left, sorry, my mistake, into left side and right side. It's not clear. Side, left side and right side. So we have the left side and right side. When the pressure in the left side, that includes pressure at point A, PA, and the pressure in the left curved part of the manometer, balances the pressure at the right side, which is atmospheric pressure, and the pressure in the right curved part of the manometer. When the pressure at the left side balances the pressure at the right side, the whole arrangement or the whole system will be in equilibrium. And our requirement or our aim is to find out PA. So from this equilibrium condition, I wish to call it as the equilibrium condition. From this equilibrium status or equilibrium condition, we can find out the pressure at A. Okay, I hope that part was clear to all of you. Now comes the next most important step, fixing of data. Fixing of data. Now I'm going to draw a line and I'm going to mark it as datum, dt, that is datum itself. Now the region on the left side below the datum, I'm going to mark it as region P, and the region below the right side of the datum, I'm going to mark it as R. Now we can say that the pressure at region P is equal and opposite to pressure at region R. Is equal and opposite to pressure at region R. we know that by hydrostatic law, pressure equal to rho times GH, rho into G into H. If we look the region below the datum, we can say that the fluid are same at region P and region R. The fluid are the same, hence the rho value will be same. The acceleration due to gravity G will also be same, and H, the vertical height or concerned vertical height, will also be same. But the direction in which these two pressures are acting will be different. I wish to change that different to opposite. So the direction in which these pressures are acting will be opposite, and the magnitude will be same. So we can confidently say that the pressure at region P and pressure at region R are equal and opposite. Hence we can neglect those two pressures, the pressure below datum. Irrespective of left side and right side, the pressure below datum can be neglected, since the rho, the G and the H are the same. Now okay friends, I am going to draw a line and I am going to mark it as datum. Here also, in this case also, I will get two regions, region P and region R. Now the pressure at region P will be equal and opposite to pressure at region R. That's quite obvious. Rho is same, G is same, H is same. But if you look close, you can understand that we have neglected this much region, this much fluid, or this much, that much pressure. We have neglected it. So instead of drawing here datum, if we draw here, the green line as datum, our calculation will become much simpler and we can save much time. So always fix datum such that our calculations can be made simpler. There is another case, an extreme one. Imagine that we are fixing datum over here. Here also we will get two regions, P and R, but the pressure at region P and region R will not be equal and opposite. This will not be the case, because the region P has two different liquids while region R has only one liquid. Region P has our orange liquid and our manometric fluid, and the density of orange liquid and our manometric fluid will not be same. Therefore the pressure at region P and pressure at region R will not be same. Okay, so always fix datum such that the pressure below the datum is equal and opposite on left side and right side respectively. So the rest of the portion will be in the second video. So do watch the part 2 of this video. Thank you.